Before adding more detail and tiling the city blocks, let's do a test render. If you need to, open the file named cityblocksroadslighting.max to follow along. Zoom in on the first city block and create a target camera along the center road. If the top view is maximized, press Alt-W to go back to a 4-viewport configuration. Activate the perspective view and change it to show the camera point of view. Remember that you can press C to set a view to a camera in the scene, and P to set it to a free perspective. Currently, the camera and its target are sitting on the ground. Using the Move tool, set the camera's Z position to 1.8 meters. That's about 6 feet high. Leave the target alone for now. Render the camera view. There's obviously some work that needs to be done. On the one hand, the black background is quite unappealing, but also the road markings seem to go bad in the distance. You'll get to the road markings in a moment, but first you work on lighting and background. From the Create Systems panel, click the Daylight button. A dialog appears suggesting that you should use exposure control, which is standard when using the daylight system. Click Yes to accept and dismiss the dialog. Click and drag in the top view to create a rose compass, and then drag a bit more to set the orbital scale. Set the hour of day to 14 or 2 p.m. You'll be able to change that as you move ahead with your project. In the Modify panel, set the sunlight to work in MR Sun mode. This makes sense since you are using the mental ray renderer. Set also the skylight to MR Sky. Again, this is the best option to use in conjunction with the MR renderer. A prompt suggests that you should use the MR Physical Sky type. Click Yes to proceed. The MR Physical Sky uses a gradient that changes color based on the time of day. It looks fine for clear skies, but to make it a bit more believable, you will use a custom background with clouds. Open the Environment and Effects dialog. You can use the render window to that effect. You can also use the rendering menu or press 8 on the keyboard. Open the material editor as well. In order to minimize potential errors, switch from the Roads view to View 1. There is an unused material in there that was previously applied to the reference plane. Go ahead and delete it. You won't need it anymore. Drag the MR Physical Sky map from the Environment dialog into the Material Editor as an instance, so you can edit it. Drag out the Background Map socket and choose Bitmap. Use the image Clouds 360 JPEG that you downloaded for this tutorial. Actually, this is not a true spherical map, but rather a hemisphere. Double-click the new bitmap node to adjust its properties. First, set it to work in environment mode as a spherical environment. Since this bitmap is only a hemisphere, you need to make a few adjustments to make it work. Set the V-tiling to 2. This effectively says you want the image to affect both the north and south hemispheres of your virtual environment. Next, set the V-offset to 0.25 to ensure the equator is a tile divider line. If you were to render the camera view at this time, you still won't be able to see the effect of the cloud's image. For that, you need to double-click the MR Physical Sky node and enable Use Custom Background Map. Try a new render. If the horizon line is a tad too high, you can adjust the V-tiling and V-offset values. In this movie, we'll use 1.9 and 0.24 respectively. Needless to say that a true 360-degree spherical map would work better, as you would not need to make those adjustments. However, they are harder to come by or create, so this will do for our needs. Next, you adjust the road markings and their distance blur properties. You can help by increasing the anti-aliasing quality, but that in itself is not enough and it does increase render time. The alternative is to adjust the bitmap properties. In the Material Editor, go back to the Roads view. There are 12 road markings bitmaps used in the material definition. Zoom in on the top one and double-click it. Note the blur value with the default of 1 in the coordinates rollout. This is what affects distance blur. The smaller value makes the bitmap crisper. However, you typically don't want to go too low, as a bitmap that is too crisp often shows jagged edges. You could change the individual blur values of the 12 bitmaps, or better yet, you can set a single node to control all of them. Right-click and choose to add a Bezier float controller. To wire it to the blur value of the first bitmap, you first need to expose that value. Right-click the bitmap node and choose Show Hide Slots, Additional Parameters, Coordinates, Blur. Now expand the node until you see the blur value. Connect the controller to it. Next, expose the blur value of the second bitmap. Connect the same controller to it. Now the controller acts as an instance. A value change at the controller level changes the blur value of the connected bitmaps. Repeat for all road marking bitmaps to ensure that one float controller is master to all of their blur values. Set the blur value to 0.2 across the board and try another test render. This looks better, although understandably, the scene is still awfully bare. Obviously, you still need to populate the city blocks with buildings, but there's still some work to be done before you get there. In fact, there are some important urban components that are still missing. Things like light poles, traffic lights, mailboxes, fire hydrants, and even bus shelters can go a long way to make the scene look more believable. Save your file. This wraps up the roadwork section of this tutorial series. In the next movie, you start with the next installment, which shows you how to merge and place urban design components.